Imagine receiving a message that has been traveling through space for more than 13 billion years. Every tiny beam of light reaching us today is a time capsule, carrying information from an era when the universe was still in its infancy. That is exactly what the James Webb Space Telescope was built to study. Instead of simply looking farther into space, Webb is looking farther back in time than any telescope before it. For decades, astronomers believed they had a solid understanding of how the universe evolved after the Big Bang. According to the Standard Model, the first stars slowly formed from giant clouds of hydrogen and helium. Those stars eventually grouped together to create small galaxies. Over billions of years, these galaxies collided, merged, and gradually became the magnificent spiral and elliptical galaxies we see today. It was a simple story. The earliest galaxies should have been small, irregular, and relatively primitive. Large, well-organized galaxies were expected to appear much later. Then the James Webb Space Telescope began sending back its first deep space observations. Scientists aimed Webb toward tiny patches of sky that looked almost empty. Previous telescopes had detected only faint points of light in these regions. But Webb's incredible infrared vision uncovered something astonishing. Hidden inside those tiny specks were entire galaxies, far more galaxies than anyone expected. Even more surprising was their appearance. Instead of looking chaotic and unfinished, several of these ancient galaxies already showed clear structure. Some appeared surprisingly bright. Others seemed remarkably massive for their age. A few even displayed organized shapes that astronomers believed should not have existed so soon after the birth of the universe. Imagine walking into an empty field where construction had supposedly just begun, only to discover a fully built city standing before you. That is similar to the surprise scientists experienced. Naturally, researchers questioned the observations. Could the telescope be wrong? Were the galaxies actually closer than they appeared? Distance measurements in astronomy are extremely complex, relying on how much light has been stretched as the universe expands. Even a small error could dramatically change the estimated age of these objects. But as additional observations arrived, the pattern remained the same. Again and again, Webb found galaxies that seemed to have formed only a few 100 million years after the Big Bang. In cosmic history, that is an incredibly short amount of time. The discoveries raised a difficult question. Did galaxies somehow evolve much faster than scientists had predicted? Or are important pieces of the universe's early history still missing from our understanding? The surprises didn't stop there. By studying the light coming from these distant galaxies, astronomers can identify the elements they contain. Every chemical element leaves behind a unique fingerprint in light, allowing scientists to determine what these ancient systems are made of. What Webb revealed was unexpected. Many of these early galaxies already contained relatively heavy elements such as carbon and oxygen. These elements are not produced during the Big Bang itself. Instead, they are created inside stars through nuclear fusion before being released into space when stars reach the ends of their lives. That entire process takes time. Stars must first form, burn through their fuel, and eventually die before enriching space with heavier elements. Yet Webb suggests this cycle may have happened far earlier than many researchers expected. If these observations continue to be confirmed, they could mean that the first generations of stars formed, evolved, and disappeared at extraordinary speeds. Another mystery soon emerged. At the centers of several distant galaxies, astronomers found evidence suggesting the existence of enormous black holes. Some appeared to possess masses millions, or even billions, of times greater than our Sun. According to current theories, black holes usually grow over immense periods by absorbing surrounding gas, dust, and even other black holes. So how could such enormous objects already exist when the universe itself was still so young? Scientists are actively investigating several possibilities. Perhaps some black holes formed directly from extremely dense regions shortly after the Big Bang. Others suggest unknown physical processes may have accelerated their growth. At this stage, however, no single explanation has been confirmed. That uncertainty is exactly what makes Webb's discoveries so exciting. Rather than disproving modern cosmology, these observations are helping scientists refine existing theories and explore ideas that were once considered unlikely. Every new image collected by the James Webb Space Telescope reminds us that the universe is more complex than we imagined. Instead of answering every question, each discovery opens the door to even greater mysteries. If the first discoveries from the James Webb Space Telescope surprised astronomers, the next findings were even more difficult to explain. The deeper scientists looked into the ancient universe, the more they realized that the earliest chapters of cosmic history may have been far more active than anyone had imagined. One of the biggest mysteries involves the shapes of these distant galaxies. According to traditional models, the first galaxies should have been messy collections of stars and gas. Frequent collisions and intense gravitational interactions were expected to prevent orderly structures from forming for billions of years. Yet Webb's observations suggest something different. Several ancient galaxies appear surprisingly organized. Instead of random clouds of matter, they display compact centers, defined structures, and signs that they had already undergone significant evolution. While these galaxies are not identical to modern spiral galaxies like the Milky Way, they seem much more developed than earlier predictions suggested. This raises an important question. What allowed these galaxies to mature so quickly? One possible explanation involves dark matter, the invisible substance believed to make up most of the universe's matter. Although dark matter cannot be seen directly, astronomers know it influences the movement of galaxies through its powerful gravitational effects. Some researchers believe dark matter may have acted as a giant cosmic framework, allowing ordinary matter to gather more efficiently than expected. If that idea is correct, galaxies may have assembled faster in certain regions of the early universe. However, this remains an active area of research, and scientists continue testing multiple theories. Another remarkable discovery comes from the chemistry of deep space. Using its highly sensitive instruments, the James Webb Space Telescope has detected complex carbon-containing molecules in extremely distant regions of the universe. These compounds are considered important building blocks for many chemical processes associated with life. This does not mean life has been found. Instead, it shows that the ingredients needed for complex chemistry were already present surprisingly early in cosmic history. That finding suggests the universe may have become chemically rich much sooner than previously believed. If future observations confirm this trend, it could expand the number of environments where scientists search for potentially habitable worlds. Perhaps the greatest lesson from Webb's discoveries is not that our current theories are wrong, but that they are incomplete. Science advances by testing ideas against new evidence. Every unexpected observation encourages researchers to improve existing models, gather additional data, and ask better questions. This process has transformed astronomy many times throughout history, from discovering that Earth orbits the Sun to realizing the universe itself is expanding. Today, the James Webb Space Telescope is continuing that tradition. Every week, it collects light that began its journey billions of years ago. Those ancient photons carry information from a universe that existed long before our planet formed, long before the first oceans appeared on Earth, and long before humans ever looked toward the stars. Each new observation adds another piece to one of the greatest puzzles in science. How did the first galaxies grow so quickly? Why do some ancient systems appear more mature than expected? How did enormous black holes reach such incredible sizes in such a short time? And are there still unknown processes that shape the young universe in ways we have yet to understand? The answers will not arrive overnight. Astronomers around the world continue analyzing Webb's observations, comparing them with computer simulations and searching for additional evidence. Some early interpretations may change as more data becomes available, while others could become landmark discoveries that reshape modern cosmology. That is the true excitement of scientific exploration. The James Webb Space Telescope has not rewritten the history of the universe overnight. Instead, it has opened a new window into cosmic history, revealing details that were hidden for billions of years and inspiring entirely new questions about our origins. As technology continues to improve, future observatories will work alongside Webb, exploring even deeper into space and further back in time. Together, they may eventually uncover the complete story of how the first stars, galaxies, and black holes came into existence. Until then, one fact remains undeniable. The universe is proving to be far more fascinating, more complex, and more mysterious than anyone expected. And with every new image sent back by the James Webb Space Telescope, humanity moves one step closer to understanding the incredible story written across the cosmos. If you enjoyed this exploration, be sure to like the video, subscribe to the channel, and let us know in the comments. What do you think Webb will discover next? The next breakthrough may already be traveling toward us at the speed of light.